The vast ocean has opened up new horizons. Over the course of a year, the changing seasons traverse the plains, inspiring everyone. On the mountains, snow falls. In the forests, trees and plants thrive. Free animals roam wildly in nature. As time went on, some of them learned to harness fire, built cities, and turned shared ideals into reality. They waged wars, painted the Mona Lisa, erected the Great Wall, and managed to take flight. All of this happened under the same sky, year after year, season after season. This is Earth, our home. And yet, for those looking from the outside, Earth is just a pale blue dot, an unnamed blue speck in the infinite universe, a fragile planet orbiting a very ordinary star, the Sun. Meanwhile, the Sun is merely a grain of sand in the Milky Way galaxy. For anyone out there to find us, they'd have to be incredibly lucky. Perhaps one of those civilizations out there is pondering the very same thoughts we've just discussed. Perhaps they, too, see themselves as a pale blue dot. Maybe their planet is even better than ours. This is exactly what recent studies of data from the Kepler mission suggest. But what might these planets look like? What characteristics could they have? Let's explore the answers to these questions together. Kepler is a space telescope designed to observe a portion of the Milky Way galaxy in search of planets outside our solar system. Using data from the Kepler mission and its K2 mission, scientists have identified over 2,800 candidate planets, of which more than 2,600 have been confirmed as actual exoplanets. Some of these planets are believed to be rocky, like Earth, but larger, and they orbit their stars in the habitable zone, where liquid water might exist. NASA's Kepler Space Telescope worked in deep space for 9 years, collecting data that has revealed these findings. Hidden in the vastness of space are billions of planets, outnumbering the stars. However, the Kepler telescope has now run out of fuel necessary for further scientific operations. NASA has decided to retire the spacecraft into its current safe orbit, far from Earth. Kepler has left behind a legacy of over 2,600 confirmed exoplanets, many of which could potentially harbor life. These are the so-called terrestrial exoplanets. Through its groundbreaking discoveries, NASA's Kepler mission has fundamentally reshaped our scientific understanding of Earth's place in the cosmos. Before Kepler, our knowledge about exoplanets was limited. For instance, how many planets might exist beyond Earth? Which planets are more common? Large gaseous planets like Jupiter, ring giants like Saturn, or Venus-like terrestrial planets? Are Venus-like planets unique to our solar system? If they exist elsewhere, why? These are all fascinating questions that Kepler has helped bring to the forefront. The universe, however, is always a bit more creative than we are. Here's what we've learned since Kepler. The number of planets exceeds the number of stars. Kepler has proven that in our galaxy, there are more planets than stars. This discovery has completely transformed our scientific understanding of Earth's place in the universe. Small planets are common. The Kepler telescope revealed that our galaxy is filled with Earth-sized worlds. Recent analyses of Kepler's findings concluded that between 20% and 50% of planets visible in the sky could be small, rocky planets similar in size to Earth, located within the habitable zone of their parent stars. These zones are where water might collect on a planet's surface. As for whether life exists on any of them, we still have much to learn. Planets are diverse. Kepler uncovered a wide variety of planetary types, showing us new possibilities. Interestingly, the most common size of planets discovered by Kepler is different from anything we see in our own solar system. This diversity opens up exciting questions about the nature of planets and the potential for life beyond Earth. They do not exist in our solar system, and there is still much we need to learn about these planets. The solar system itself is also diverse. While our inner solar system has 4 planets, Kepler discovered that many systems in other galaxies have planets orbiting much closer to their parent stars. The existence of these compact systems raises questions about how solar systems form. Were these planets born close to their parent stars, or did they form farther away and migrate inward over time? New discoveries about stars. Beyond ushering us into the golden age of exoplanet exploration, Kepler also revitalized the study of stars. During its 9-year mission, Kepler observed over 500,000 stars. As you can see, if Kepler taught us one thing, It's that the universe is often different from what we imagine, yet there are still some common features. This is why the search for Earth-like planets remains so important. As we know, these planets could potentially harbor life. As we've mentioned before, Kepler has indeed detected some exoplanets, many of which, as far as we know, are inhospitable to life. Additionally, there are planets made entirely of iron. Some planets are even brighter than certain stars, and others are larger than Jupiter, orbiting their stars at a very close distance. We don't yet know how to explain this strange behavior. But Kepler has also discovered Earth-like planets. Planets that seem like home, but to us, they would appear as tiny blue dots because they have water, covered by oceans, and perhaps some of them are currently hosting some form of life. Kepler has detected and studied planets about the size of Earth, orbiting at a safe distance from their host stars. This orbit lies within what is known as the Habitable Zone, or Goldilocks Zone, where temperatures are just right. Water can condense on its surface, but won't be cold enough to completely freeze. While existing in this zone doesn't guarantee the presence of life, as far as we know, the presence of water is crucial for the existence of life. Kepler recently discovered an exoplanet like this, called Q18b. Researchers are very excited about it. In September 2009, two scientific teams separately announced that they had detected signs of liquid water in the atmosphere of this planet, located 124 light-years from Earth. Q208b has 8 times the mass and 3 times the volume of Earth. It orbits a red dwarf star, Kepler 18. But what about Mars? The red dwarf star is the smallest, coolest, and most common type of star in the Milky Way galaxy. According to Kepler's data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in their habitable zone. This means life could exist in areas far beyond where we are now. The more we think about it, the more it gives us great motivation in the search for life. Who knows? Maybe in the coming decades, Kepler's successors will finally prove that we are not alone in the universe. But how did Kepler find K2U8b? In research practice, searching for exoplanets has almost never truly meant searching for exoplanets directly. Instead, we observe the stars that seem to be the best candidates for having planetary systems. We study their light and break it down to look for signs of other worlds. For example, we observe how their light changes periodically. This is due to the transit method, or the slight movement of a star here or there, affected by the gravitational influence of an unseen planet, which results in a small change in the star's speed. Kepler discovered K2U8b through this method. Now, a new study suggests that another exoplanet, K186f, located 500 light-years away, may also have signs of life. In addition to seasons and climates similar to ours, new research from Georgia Tech analyzed the rotation and axial tilt of this planet, finding that its tilt is stable, just like Earth's. This makes Q86f likely to have regular seasons and a stable climate. If you lived on that planet, you might not experience any drastic seasonal changes. It would be similar to Earth, with autumn, winter, spring, summer, and so on. Universities around the world are conducting similar research on the Kepler database. In fact, in recent years, discoveries made before Kepler were considered potential Earth-sized exoplanets due to algorithm errors. These discoveries are now being rediscovered. These false positives are slowly being reanalyzed along with data from other telescopes. Kepler 1649c is one such star. In mid-2020, astronomers sifted through Kepler's old data, and by comparing this with new data from the TESS, Transiting Exoplanet Survey satellite, the existence of another exoplanet was confirmed. Kepler 1649c, located 300 light-years from Earth, has conditions very suitable for the existence of life. It is very similar to Earth in size and estimated temperature. This newly discovered planet is just 1.06 times the size of Earth. The amount of light it receives from its host star is about 75% of the light Earth receives from the Sun. This means the temperature on this exoplanet may also be similar to ours. Kepler 1649c provides another example of an Earth-sized planet in the habitable zone of its star. Since the Kepler mission was canceled, people may wonder what the next mission is. Before we find the answer to that question, make sure to follow so you don't miss any exciting videos. As for the current missions studying exoplanets, there are a few things we should know about them. The TESS, Transiting Exoplanet Survey Satellite Mission, is one of them. It is part of NASA's Explorer program, with the goal of using the transmit method to search for exoplanets. The mission's primary objective is to examine the brightest stars near Earth and identify planets passing in front of them over the course of 2 years. TESS uses wide-angle lenses to observe the entire sky. Thanks to TESS, through subsequent investigations, we have the opportunity to study the mass, size, and density of these planets. This research primarily focuses on stars similar in size to Earth and super-Earths with rocky surfaces in the habitable zone of their stars. This exoplanet characterization satellite will be the first dedicated to searching for transmit events using ultra-high precision photometric technology on bright stars known to host planets. Because it can point to almost any location in the sky, it will provide a unique ability to determine accurate magnetic poles for planets whose mass has already been estimated through ground-based spectroscopic surveys. It will also provide precise radius measurements for newly discovered planets observed with next-generation transmit observation. The IP telescope is designed to observe objects in the infrared spectrum, proving to be a revolutionary tool for studying the characteristics of exoplanets. This mission is the first instrument capable of directly detecting the light of exoplanets, and its data has revealed the composition, temperature, and even potential patterns of distant exoplanets. Spitzer was the first telescope to directly detect the light of exoplanets outside our solar system, marking a new era in planetary science, essentially allowing for direct study and comparison of these planets. The infrared astronomy also made it possible to measure the temperature, winds, and atmospheric composition of these distant planets. Before Spitzer, all confirmed exoplanets were detected indirectly, primarily through passive techniques, and more recently through transmit techniques. In the first method, a planet is detected through the gravitational pull it exerts on its host star, causing the star to move passively. In the second case, the planet's existence can be inferred when it passes in front of its star, causing the star to dim or flicker. Both methods used visible light telescopes and revealed the planet's mass and size. Spitzer extensively used transmit technology. Thank you for watching. This is Information Small World. Please continue to follow for more exciting content.